All right, so welcome back. Hopefully you knocked out the Google tutorial lab and you have a lot more like information from Google about how they do things. Some things are a little different than mine, and we can talk about that. But it was supposed to just kind of be a good introduction to App Engine from Google after you've got a little experience. What we wanted to kind of kick off now is talking more about data models, and what we're going to do is we're going to talk some details, and then I'm going to have you kind of design the data model for the grade recorder. Is kind of the idea. So let's kind of talk about data models a little bit. So there are two important elements to all data store models, and that's the key and the entity, right? So the key is what points to the items that are in the data store. One way you can get items out of the data store is by knowing their key or having their key, and that's basically a pointer to the data, right? And the keys have a structure, and the entities also have a structure. So entities, as you're kind of more familiar with from the movie quotes and other things, they have different types. So like you might have a string property as being one of the objects in your entity. We've also used integer property. No, not yet, but we will. And then there's another type that we'll kind of introduce here. There's also a property called a key property, which, as you probably have guessed, is another key, right? So it's a key that points to somebody else's data. And so this is one of the ways you can do relationships in the data store, right? There's a couple different ways, but I consider this to be kind of one of the primary ways. Is you have an entity which has a key property that points to somebody else. And so we'll be learning about that some with the grade recorder. The other thing I wanted to make sure you're aware of is the way keys work in a tree structure. So keys will typically have a parent, and that parent might have a parent, and that parent might have a parent. And ultimately, at some point, you're going to get to a key which has no parent, which is called a root key. So you might not have any parents. You might just be a root, and you might point to an entity, and that's great. And then these other keys, they might point to their own entities, or interestingly enough, they might not, which is kind of a crazy thing. You can have a key without it pointing to something. We'll talk more about that. But I wanted to make sure that you were kind of aware that there is definitely a structure to keys. Let's talk more about keys. So a key consists of three things. So the idea of a key is it has to be able to uniquely identify an entity. That's what it does. So one of the things in the key is the kind. So obviously for movie quotes, the kind was movie quote, right? If you remember way back, movie quote actually had a parent key, which did not point to an entity. We called that one entity. The app that you just did for guest book, it had what did it have? It had a guest book parent, and then I think the other one was called greeting. So it had like a guest book and a greeting. And these are all examples of kind, right? So these are kinds. Next thing in it is an identifier. So an identifier comes in two flavors. An identifier can be a key name or it can be an ID, never both. So it's one or the other. The key name is when you type the string. So for some reason you've actually picked a string. It turns out that in movie quotes we actually just hard-coded it. It was called movie quote root, I believe. I don't know if you can read that, but it's movie quote root. And then in the guest book, it was like whatever you specified as the name of that guest book. So for example, it used default guest book name that was the name key for that key, right? And so that's one you can specify. ID is a random number, right? So ID is just a random number. They used to actually number them in order. So you'd get like ID number 1, and then 2, and then 3, and then 4. They found it's more efficient, though, to just shotgun and just give you like 10 digits for all the things. There's a little efficiency boost in doing randoms. Those two things you kind of expect. And then the third one is that ancestor path. So it points to its parent. And some people, when you read it, it says that it's just the parent's path. And then other people say it's the ancestor path because it's recursive in nature, right? So it points to your parent, which then points to its parent and its parent and its parent up until you've got a root. So these are the three pieces that go into a key. And if you know these three things, then you can identify a particular entity that's in the data store. Let's look at some examples. So here's kind of a silly example. So we've got an entity. So here's our entity. Our entity is of type person. A person, we've decided, has a name, which is a string property, and then they've also got a birthday, which is a date time property, and they've got a spouse, which is a pointer to another key property. Obviously, a person has a lot more than that, but I wanted to pick some things that were different property types, right? And so this is the structure of the entity. Then let's pretend like this is the key, right? So this key has a parent, who has a parent, who has a parent, who finally has another parent. In this example, they're all people as the kind, and instead of letting them be random keys, I've actually just given them a name just to kind of make sure you've got an idea for who they are. So there's the great-great-grandfather, the great-grandfather, the godfather, the dad, and then there's me, right? So if I look at my key, I consist of three pieces. I consist of my kind, my identifier, which in this case is a name, a key name, and then I consist of my ancestor path. So who all was a part of my ancestry, right? So this is an important structure to kind of know how keys work. There's also a term called entity groups. So for example, this whole thing is part of the great-grandfather entity group. So let's go ahead and talk a little bit more about entity groups. So the entity group structure is such that a key, so this is the great-grandparent, can have as many children under him as he likes, right? So shown here is 3 because wherever I ripped the graphic off from, there are 3. But he could easily have, thousands, right? So you can have as many children as you want. But note that if you kind of look backwards, every key has only one parent. So if somebody was to kind of draw a chart that looked like this, this is nonsense, right? This is very much not how keys work. So don't try to do something like that. So each key has exactly one parent, and that's kind of the structure of the app. Other things that I want to just kind of clarify, you've seen this a couple times, but a key need not point to an entity. So you can definitely make keys that don't point to entities, and they're still part of the ancestry, right? So for example, in the movie quotes app, we wanted strong consistency. So we made a key that was fictitious. It didn't point to anything at all, but that gave us strong consistency because then when we put the data in, we put it in with that parent, and then when we did our query, we did an ancestor query, and that gave us strong consistency. And you've actually seen that twice now. So the guest book did the exact same thing, right? So they had a key, which was a guest book. The ID was whatever name you gave it. So for example, if you made a guest book with the key name Rose, that's the key. It didn't point to any entity. And then you'll notice that the greetings, they let a randomly generated ID come together. So somebody at Google, when they were thinking about this tutorial, they designed a data model. And to be honest, they designed a very simple data model. And it's no coincidence that the data model that they designed and the data model that we designed in movie quotes are quite similar. The only way they're different is that we have only one parent, whereas in theirs, they let you assign different guest books, right? So that's an important thing to say about keys. The other thing I want to say about keys is you've probably seen the urlsafe in some of the work that we've done. You also saw it with the Google things. So a key, first and foremost, I'll say is an object, right? So it's an instance of type NDB key. If you print it out in like a logging.info, it'll print out and kind of look like this. So this is not the key, but this is the decoded view of it, right? And you can see the things that are in it when you print it out are obvious. So there's the kind, the identifier, and then the ancestor path, which in this case consists of one parent key. The other thing you'll see is whenever we pass it down to like HTML, we don't want to put it in that format because there's a lot of illegal characters there, right? So what they do is they make a URL safe version. A URL safe version consists of lowercase letters, uppercase letters, and then dash, hyphen, and the numbers, right? And if you add this up, 26, 26, 10, plus 2 more, it comes up to be 64. So it's what's called a 64 base 64 encoded string. So the nice thing about it is this really is just a string, and you can pass it around. And if you pass it down to your page, it's safe on the page. You don't have to worry about these double quotes and colons and nonsense. So it's just a simple string. There's no spaces in it as well, which is nice. And you can pass it down, and then if it ever gets passed back up, there's a constructor for an NDB key that lets you pass in the URL safe version. And what it does is it converts that URL safe version back to the key object, right? One thing I wanted to point out, and this Google points it out as well, is this is not encoded. So it's not safe to like pass around. It's not encrypted. It's just in a version that's easier to pass around. It's URL safe. If you looked at their algorithms for how they generate these, you could back out what the key was. So don't think that it's encoded. It just is easier to pass around. The data, like if you wanted to go look up information, is a lot of great Google Docs. I've got some links here. Like you should definitely just go read these things, right? So this first one, it'll take you 2 to 5 minutes to read it. And it's just the concepts overview. It's the things you already know, but maybe it'll help cement them in your mind. And then if you wanted more information about NDB and NDB keys, this bottom link here is specifically about the key class. But I wanted to warn you about something. This first link is about the Datastore only. Turns out you can use the Datastore without even using App Engine, right? So you could you could have a Node.js server that chooses to save its data with the Datastore, and there are client APIs for doing those transactions. And if you go to this link, if it says Datastore in it, it's going to be showing you those client APIs. That's not how we're using it in this class. We are very much using the Datastore via App Engine. So these later links say App Engine in the name, and those are the ones you want. And so specifically the words Python NDB and the Datastore, they are the same thing. But if you go to these early links, you'll get really confused because the code is like all different. Whereas if you go to anything that says App Engine, Python NDB, that's going to be the style of code that we're using. So now that you kind of know these things, I'm going to leave you with one little challenge at the end of this lecture. And that's, I want you to go to Grade Recorder. So you can go to the Fisher DS version, or you can probably go to the other version as well. And I want you to play around with it. And as you're playing around with it, I want you to be thinking, what are the entities here? So what are the entities? How many are there? What are the properties that are each entity are going to need? So, you can look around and you can kind of see like, here's some things that students have. So this is probably a pretty good idea of what goes into that entity. I also want you to think about how would you structure this app? So obviously one user can't see other users' data. So there's something that keeps it restricted to a user. So I want you to try to think about what are the different entities that I would need, just to kind of get you thinking about it. Like, does there need to be an entity for a user? How are you going to set that up? Maybe there's one for a student. Maybe there's one for the teams, the assignments, the grade entries. Play around some with the CSV files. Think about, will that need anything on the back end or not? Like, how's this going to set up? And then, like, what entities or what properties are going to be in that entity? And then I'd like for you to even go a step farther and think about the keys themselves, right? So what are the data models you'd use? If you're a programmer, this is basically a UML diagram, right? And then the things that kind of make it specific to App Engine is what is the hierarchy going to be, right? So if you were to draw a key, what children would it have? Maybe the children have children. How are you going to set this thing up? And then each of these, so let's say that there's a student one, right? Each of these would point to an entity. And then the entity for say a student, it would have different properties associated with it. So it doesn't have to be in these slides, right? Just get out a sheet of paper, make yourself a little UML diagram to think about the data that's going to be in here. And we're going to kind of answer this question in later videos, right? All right, so that's all for this time. We're going to come back next time. We're going to start hitting the code hard on Grade Recorder. We'll see you then.